In this problem, we are given 13.4 grams of sulfur, and we are to determine the amount of atoms of sulfur this is. So our pathway for solving this problem is we're going to go from grams of sulfur to moles of sulfur, and we're going to end with atoms of sulfur. To go from grams to moles, we can use molar mass, which we obtain from the periodic table. To go from moles to atoms of sulfur, we can use Avogadro's number. Now that we've established our pathway, we can go ahead and plug in the information that's given. We start off with what's given, which is 13.4 grams of sulfur. And now we need to go to moles of sulfur using molar mass. If we go to the periodic table, the molar mass of sulfur is 32.065 grams per 1 mole of sulfur. And we can convert from moles to atoms of sulfur using Avogadro's number. We want moles at the bottom so we can cancel out moles, and Avogadro's number is at the top. So moles of sulfur cancels out, grams of sulfur cancels out, and this is going to be reported to 3 significant figures. Avogadro's number has 4 significant figures, and we have 3 sig figs that we're comparing to, so we're going to report it to 3 significant figures, and therefore our final answer is 2.51 times 10 to the 23rd sulfur atoms. In the next example, we have 3 grams of potassium phosphide, and we want to determine the number of potassium atoms. So let's go ahead and write down our pathway for solving this problem. We're going to start off with grams of potassium phosphide, and then we're going to go to moles of potassium phosphide. From moles of potassium phosphide, we're going to go to moles of K. And from moles of K, we're going to reach atoms of K. To go from grams to moles, we use molar mass. To go from moles of K3P to moles of K, we're going to use our mole to mole ratio. For every 1 mole of K3P, we have 3 moles of K. Because if you look, potassium has a subscript of 3, so there's 3 moles of K for every 1 mole of potassium phosphide. And then in our last step, we're going to use Avogadro's number to go from moles to atoms. So let's go ahead and also calculate our molar mass for K3P, since we're going to use that to go from grams to moles. So we're going to take 3 times the molar mass of potassium plus 1 times the molar mass of phosphorus. And the molar mass of phosphorus is 30.974. And so this ends up equaling to 148.268 grams per mole as the molar mass of potassium phosphide. Now that we have the molar mass of potassium phosphide, we're going to plug in the information that we have. We start off with what we have is 3 grams. Three grams of K3P, and we're going to divide by the molar mass, which is 148.268 grams of K3P to 1 mole of K3P. And then our next step, now that we've converted to moles of K3P, we're going to get to moles of K. And we know that for every 1 mole of K3P, we have 3 moles of K. And now we're going to use Avogadro's number to get to the number of atoms of K. So every 1 mole of K, we have 6.022 times 10 to the 23rd K atoms. So if we look at the number of significant figures also, our answer will be reported to 2 significant figures. Our moles of K cancels out, our moles of K3P cancels out, and grams of K3P cancels out. So to 2 significant figures, our answer is 3.7 times 10 to the 22nd potassium atoms. In the last problem for this page, we have 1.50 times 10 to the 25th atoms that weighs 398.7 grams. And we want to determine what the molar mass is. Remember that molar mass is equal to grams of element X over the moles of element X. If we look at this problem, you can see that we are given the grams of element X. So half of the problem is done. That's already our numerator. We need to be able to convert these atoms to moles so that we can get the denominator and then divide the two to obtain our molar mass. So what we need to do is go ahead and convert atoms of X, atoms of element X, to moles of element X using Avogadro's number. So we start off with what's given. It's 1.50 times 10 to the 25th element X atoms. And we know that in Avogadro's number of atoms, we have 1 mole of element X atoms. So our atoms cancels out and we're left with moles of element X, and that will end up being 24.9 moles of element X atoms. So we have the denominator, and now we can go ahead and divide the two. We have 398.7 grams of element X divided by 24.9 moles of element X. This ends up being 16.0 grams per mole. That's the molar mass. What element is this? If you go to the periodic table, this is oxygen.